Hello everyone, welcome back to Chemistry First Day. Do you have any comments for my first video? Please comment down and share with me and then I will improve, okay? Trust me, I will improve, okay? So before we talk about elements, so now we talk about the nuclear atom. We are still on S1, okay, S1.2. Remember S1 is about the model of the particular nature of a matter. What does a matter consists of? Before we say is elements, atoms. Now we go inside what is an element. Okay, the nuclear atom and what is atomic structure. When you talk about structure, it means really to break down the atom, right? Remember, by definition, atom elements cannot be broken down by chemical method, but we can use other physical way to break it down, so we can still understand the subatomic nature of the atom. What is the structure of an atom? Okay, lots of sophisticated theories here, all come from different experiments and lots of data, and they come up by this conclusion. If you want to study how can they come up with this atomic structure concept, nucleus, okay, then you can go to Google, YouTube. Okay, other people has much more video on it. Okay, about history of the discovery of the atom and whatever. And so what is the atomic structure? It means that there's smaller parts of the atom, so we call it subatomic particles. Okay, sub means smaller. An atom consists of negatively charged electrons, okay, orbiting around a positively charged dense nucleus. It is a model just like the moon orbit around the earth orbit around the sun, right? It's just same. The negative electron is being attracted by the positively charged nucleus, but the electron moves so quick, so it doesn't collide with the nucleus. It keeps its orbits, okay? So the positively charged nucleus has two parts. One is a positive proton, we found it very early, and then the other is the neutral neutron. Okay, it's neutral, hard to discover, but when we try to find out the mass of the nucleus, we find out the proton doesn't consist of all the mass of the nucleus, so we think that there must be something inside the nucleus that has a low charge. Okay, and later on we find out it is a neutral neutron. And negatively charged electrons occupy the space outside the orbit. Remember, the electron orbits around the nucleus. Okay, so the size of the atom depends on the outermost shell electron, the outer one. The farthest away electrons orbits is the radius of the atom. And give you a concept, the radius of the atom is about 10 to the power 5 times the standard radius of the nucleus. So nucleus is very, very small, okay? They said that is the big soccer field, the biggest soccer field, okay? It's the atom, then the nucleus will be the soccer ball at the center. Wow. And then subatomic particle is all the particle consists of a makeup of the atom. So we can say protons, neutron, and electron. Later on, we'll find out they have some fancy properties, very symmetry property. To me, it is just like a miracle. Okay. The magnitude of charge of a proton, you know, is positive charge, okay, and then electron is negative charge, but they are from fancy thing. These charges, their charges are exactly the same but opposite. Really amazing. A proton and neutron has very different other properties, but the charges are exactly cancel. So when a proton and a neutron join together, they are exactly neutral. This neutral is very important to us. So because their charges are identical, so we can even say that the charge of a proton is a +1. Actually, it's a +1 E. E is a number. In physics, you learn it is, you learn later, okay. E is a very small charge, 1.6 times 10 to the power -19 coulombs. And exactly the charge of an electron is -1 E. So you can abbreviate it as -1. So it make it very easy to understand. +1 and -1. And besides the different charges, the proton and neutron are +1 and 0 charge, right? Have very similar properties, so we call them proton and neutron nucleon. Actually, in the nucleus, when it is so small, they have some nuclear strong force, okay? The strong force is much bigger than the electrostatic force, okay? So in the nucleus level, proton and neutron behave very similarly because the repulsion of the electrostatic force, the charge repulsion force is negligible in the nucleus level. Okay, so we call them both nucleon. And the proton and neutron have very similar mass. Okay, Okay, they call it one atomic mass unit, 1U. Okay, actually it's a 1.0 something, 1.0 something. Okay, very close to each other. And then an electron is much lighter than proton and neutron. Okay, mass of an electron is 5 times 10 to the power negative 4U. What's that? Okay, it means that 2000 electrons mass is 1 proton. 1 over 2000, okay, approximately. Actually, you're over 1800 and something, okay, but we are possibly at 1 over 2000. And mass of electron is negligible, okay, because it is 2000 electron is just 1 proton and neutron's mass, so we can neglect it, okay. So when we talk about mass number, we just talk about the nucleus is enough, proton and neutron, okay. And then we can talk about total number of nucleon. So mass number is total number of nucleons, okay, the same, okay. So mass number is used to represent the mass of an atom because most of the mass of an atom is in the neutron and proton, the nucleon. So number of nucleon, total number of nucleon, the mass number can represent the mass of an atom. The mass of an electron is how light? 1 over 2000. Light as a proton. And then the chemical properties of an atom depends on the number of protons, okay, and also depends on number of electron because this is an atom, is neutral, okay, we assume. So number of proton and number of electron are the same in an atom, we assume it is neutral. So a number of proton, we give it a name, okay, atomic number. This atomic number determine which element the atom is. So atom with a particular atomic number, we call it an element, okay, and each element has a name and an element symbol. For example, carbon is C, nitrogen is N. Look at the periodic table, you learn a lot from that, okay. An element is represented by this symbol, okay, AZX symbol, but be careful, A is not atomic number, sorry, A is the mass number, Z is the atomic number. Quite tricky, okay, and X is the element symbol. Look here, Z atomic number at the lower left corner, A mass number at the upper left corner, and all these are written at the left hand side. The right hand side will be reserved for the charge and the number of elements in the molecule. And number of neutrons is how to find the number of neutrons. Easy, okay, A minus Z, right? Mass number minus atomic number. Yeah, the extra, the missing mass without charge is the neutron number. And a neutral element has the same number of proton and electron. We call a neutral element an atom. Okay. So number of electron equals number of proton equals atomic number set for a neutral element for an atom. How about the charge? Okay, if it is charged, we give it another name, an ion. Charge, no matter positive or negative, we call it an ion, positive ion, negative ion, cation, anion. Okay, net charge, okay, is the number of protons minus number of electrons. Okay, for atom the same way. So Z minus Z is 0. Okay, so net charge is 0 for an atom. And positive ion, okay, we're written in this way, AZX, okay, N plus, okay. It has N less electrons, okay, ionized N times, okay. So number of electrons equal to Z minus N. And for a negative ion, AZN X N minus, it has N more electrons. So number of electrons is number of protons plus N. Very complicated. Now, when you work on more exercise, you get familiar with it, okay? Trust with me, you will encounter it over and over in the whole IBDP chemistry course, okay? So, sorry, I make a mistake, it should be neutron, sorry. A proton and neutron has a similar mass, 1U, but the charge is completely different, plus 1 and 0. This one should be 0, okay, sorry. I make a mistake. 0. And therefore, electron is much lighter, 1 over 2000, okay, and the charge is negative. Sorry, it should be 0 neutron, okay. Actual value of masses and charges of subatomic particle has some more digits, okay, it will be given in the data booklet, okay. And remember, in examination, always be careful. Composition of nucleus, no electron. Be careful. And then the other concept is isotope, okay. Isotopes are atoms of the same element. So element, what is the definition? Yes, same atomic number. But what's the flexibility? Yeah, number of neutrons is not fixed. So isotope is the same element, same atomic number, but different number of neutrons, different mass number. So we can say equal number of proton, equal atomic number, but different mass number. Okay. So a number of, and then as the number of electrons equals the number of proton in an atom, right? So isotope has the same number of electrons also, is still neutral. As the mass number equals the sum of a proton and neutron. Okay. More proton, less proton, so more neutron and less neutron, so different mass number. I know, I'm not sort of a technical term, right? If you find it hard, okay, try to read this, watch this video again. Second time you'll find it easier to follow. Just try to finish it first, okay? And so chemical properties, chemical property depends on what? Number of proton and number of electron, right? Not the number of neutron. So the isotopes of the same elements, okay, they have the same number of proton and electron, they have the same chemical properties, but it must be a little bit massive or a bit less massive, right? But the physical property might change, okay? But change a little bit, right? +1, +2, -1, -2, just a little bit for the number of neutrons. So it has a similar, but not exactly the same physical property. Remember, same chemical property. Similar, but not exactly the same physical properties. Okay, so distinguish between these two things. Physical property, chemical property. An isotope with more neutrons than the stable isotope may be radioactive. We'll learn this later. Radioactive will emit radiation and may hazardous to human and the environment. So some isotopes are radioactive. Be careful. And the mass spectrometer is a machine, okay? We want to investigate what is the charged isotope. What is the isotope, okay? The concept is inside this machine, okay, charged isotope may have different mass to charge ratio m over z ratio. And this is the teeny tiny difference m over z ratio, even to 1% we can find it out, okay? Can cause a different behavior in the mass spectrometer. This charged isotope have different bending in the spectrometer. For example, if a m to z ratio, just think about mass, okay? More massive, okay? Higher mass to z ratio, harder to bend, right? Those are smaller bending of the isotope in the spectrometer. So from the bending of the inside the spectrometer, they will know what is the mass to charge ratio of that isotope, and they can find out relative abundance too. Okay, we don't need to learn the structure, okay, how it works. Okay, it is in the physics curriculum, IBDP. Okay, so we just need to learn how it works. Okay. The result is that you put down the molecule inside the machine, okay, the machine will break it down arbitrarily into different parts, okay. So some is smaller fragments, some is bigger, okay. So this result tells you a different mass to charge ratio. They have different relative abundance, okay. And the highest peak is the most frequently appears, okay. This molecule, when you break down that molecule, this molecular mass fragment appears most, okay. Maybe by symmetry, it's easiest to be broken down into this way, this mass number. And then you'll find out some peaks are very close together. Probably they came from the same isotope, maybe sodium 21, 22, 23, right? Very close. Even they said that one different mass number, they get distinguished here. And the largest one is the one that didn't break. You just analyze it, okay? So from the largest value of the molecular mass, the peak, the farthest peak, you know the molecular mass of the unknown molecules, okay? This is the way you find out some unknown molecules. You put it in the mass spectrometer and you have some data. Combined with other data, you can find out what is the structure of the molecule. It happens always, just like in a 2025 May exam, it happens, okay? One organic compound, they ask you to use this way to distinguish it, to find it out. And the isotope okay, show the relative abundance of the corresponding isotope. So I saw this one again. So by this relative abundance, you can find out the molecular mass, or the atomic mass, or the mass number of the atom. Okay. Mass spectrometry can change the isotope with only one difference in relative atomic mass. Wow, so accurate. N14 and 15 are different. So each peak can differ by just one difference of mass number. Crazily accurate. Okay. For an element with several isotopes, it has multiple relative intensity by m over z values found by the frequency of this isotope dispar. Okay, very close to each other. So relative atomic mass is found by calculating the weighted average, okay, of this you remember mass to charge is supposed to be a integer, right? But when you calculate this one, it's an average, so the relative atomic mass can be this decimal number, okay? And this out of syllabus is the operation detail of the mass spectrum. You don't need to learn it. You can go to YouTube, you can watch another video, learn about it, okay? Maybe with 30 physics, you learn it when you talk about the circular motion in a uniform magnetic field. You learn it very soon, okay? So that is for the atomic structure, okay? Maybe a lot of keywords come out to your mind, too complicated, very complicated, but you need to get used to it. Neutron, proton, electron, isotope, elements, atom, ion, positive ion, negative ion. You do say distinguish their property, their definition clearly. Okay, so if it's the first time for you to learn it, I recommend you to watch the video again. I promise second time when you watch the video, you get more familiarized with the thing, okay? Really. See you. Thank you.